Hi, I'm Yi-Wen, a graduate student at Texas A&M University. Today I'm going to present our work, InterFlow, designing an obtrusive AI to empower interviewers in semi-structured interviews. This work is done with my collaborators Yu Zhang, Sriram Suresh, Zhicong Lu, Can Liu, and Meng Xia. Semi-structured interviews are a common method in qualitative research. However, conducting high-quality interviews is cognitively demanding. Interviewers need to actively listen, think about follow-up questions, and maintain a natural conversational flow at the same time. This can be challenging, particularly for non-expert interviewers who have not yet developed strong interviewing skills. Large language model-based chatbots have shown potential for automating the interview process. However, compared to human interviewers, they fall short in perceiving nonverbal cues and building rapport with participants. Recent studies also show that large language model has difficulty steering interviews toward desired direction or engaging in multi-turn planning for strategic dialogue. On the other side, interviewers who often self-identify as qualitative researchers value the real-time serendipity that may lead to deep insights. Empirical studies show that they expect AI to work alongside them, but not replacing them or taking the lead. So the question we ask is, instead of replacing human interviewers, is there a way to leverage AI to empower and augment interviewers in real time? To inform a design that is feasible for real-time use, we conducted a formative study with 6 non-expert interviewers, who we assume would benefit most from our tool. We found that interviewers typically use pen and paper or text editors to display the interview script and manually track their process. This makes it difficult to navigate the script. They also use meeting tools such as Alter AI to record and transcribe the sessions. However, these tools mainly support post-interview analysis, so interviewers still need to manually jot down notes as reminders for follow-ups later, which could lead to interrupted conversation. Thirdly, interviews can also easily run over time, or interviewers may later realize that certain topics were not covered enough. Lastly, in 2 of the sessions we observed, there were 2 interviewers sharing the workload. Interviewers appreciated this setup, but it was not always feasible due to limited personnel. Based on that, we designed InterFlow, an AI-powered visual scaffold that helps interviewers manage the interview flow and facilitates real-time data sense making. Now let's see some short demos of the system. InterFlow takes in the pure text script and turns it into interactive UI components that shows the structure of the script. After the interview begins, it highlights the ongoing question, and the asked ones will fade in gray. When user hover under a question and clicks Summarize button, the system will return an extractive summary of what has been said by the interviewee in the last 30 seconds. The co-interview agent keeps listening to the conversation and surfaces noteworthy points proactively. When user hover on the suggested point, the system will show further hint on how to follow up. User could also manually write down notes if they think it could not be captured by the system. On the right side, there's a minimap showing the interview progress and conversational balance. So how does InterFlow actually work? For detecting ongoing question, The system takes in the interview audio and transcribes into text in real time. We segment the transcribed content and use a dense retrieval to retrieve the most relevant question from the script. For analyzing the conversational balance, the system performs speaker diarization every 30 seconds and calculates the ratio between the speaking time of interviewer and interviewee. When the user clicks Summarize button, the system retrieves the audio from the previous 30 seconds and extracts the interviewee's speech for the language model to summarize. For the co-interview agent, we concluded the typical situations that worth following up from literature and invited 2 experts to validate and enrich with examples. We passed this scheme to the agent and used test time scaling to select the best suggestion in a sliding time window as a way for improving the quality of suggestions and ensure that they won't appear too frequent. To evaluate our system, we conducted a user study with 12 interviewer-interviewee pairs. We let them choose from 3 sets of interview scripts we prepared and conduct interviews using our system and a baseline, which consists of a chat panel powered by the same model as our system and a text editor. We collected interviewers' subjective ratings, interaction logs, task performance, and conducted exit interviews with both interviewer and interviewee. We also quantitatively measured the accuracy and latency of the core features. We invited 2 expert qualitative researchers to rate both baseline and InterFlow suggestions. InterFlow exhibited a relatively higher portion of noise and received lower ratings for its suggestions. We attribute this to the requirement of generating suggestions grounded in our predefined scheme, which is more demanding for the model's instruction following and reasoning capabilities. The user ratings here show that InterFlow reduces the cognitive load of doing interviews, helping interviewers maintain an overall picture while keeping a record of the details they considered important. The ambient visualizations and multi-level process-oriented AI suggestions impose minimal cognitive overhead and fit naturally into the interviewer's thinking flow. However, participants hold different opinions on the utility of system suggestions. Some describe them as unexpectedly accurate, noting that they faithfully reflected the underlying interaction context. Some participants felt that certain suggestions added little value because they highlighted observations that were already noticed. With all of the findings from the study, what implications does InterFlow have for future research? Our process-oriented AI assistance exposes the reasoning process, improving transparency and potentially reducing inappropriate reliance on AI. We believe this approach could be extended to other high-stakes scenarios, such as AI-assisted clinical decision-making. Secondly, users differ in how they perceive and engage with AI suggestions. This calls for finer-grained and dynamic user modeling, where a system learns implicit preferences from users' interaction history. AI-assisted interviews introduce a triadic interaction among the interviewer, interviewee, and AI assistant, where even brief attention shifts may disrupt the social engagement. Future systems should therefore explore more natural interaction modalities that deliver assistance while minimizing noticeable attention shifts. With that, I'd like to end my talk. Welcome to check out the full paper for more details and feel free to email me if you have any questions about this work.